Hello students, welcome to Kiran Pothina Maths channel. This is LPP sheet 5 from our target 80 by 80 series. In today's question, we are going to study a very important concept in linear programming problems, that is unbounded feasible region. Many students can draw the graph correctly but make mistakes while concluding the final answer. In this video, we will learn how to identify an unbounded region and how to decide whether the objective function has a maximum value or not. Let's start the solution. So before that, observe what they are asking. Like they are asking to find maximize. So maximum value we need to find by using this objective function. Subject to constraints are x greater than or equal to 3, x plus y greater than or equal to 5, and x plus 2y greater than or equal to 6, and y greater than or equal to 0. Now, so first I will consider given objective function, that is z equal to minus x plus 2y, and also I will write constraints are. So what are the constraints given? The constraints are, first I will take in two variables, that is x plus y greater than or equal to 5, and then the next one I will take x plus 2y greater than or equal to 6, and next I will also consider regarding x greater than or equal to 3. So let us solve one by one. After writing inequality, we have to convert into equation, that is x plus y equal to 5. So I will draw a table in order to find that x and y values. X value and y value. When x value is 0, y value 5. When y value is 0, x value 5. Right. Similarly, I will convert the inequality into equation, x plus 2y equal to 6. For this also I will draw the table. When x equal to 0, y value 3, y equal to 0, x value 6. Okay. Now for the third equation, no need to find points like this. I will tell you how to write the sentences for this type of inequalities. Okay. So now come to this. So what are the points? Points are 0 comma 5 and 5 comma 0. What about points here? So here the points are 0 comma 3 and 6 comma 0. So I will do checkpoint here. Checkpoint. So what we will consider generally checkpoint here? So I will consider 0 comma 0 as our checkpoint. Consider 0 comma 0 as checkpoint. Okay. Now that 0 comma 0 I will substitute in that inequality, that is x plus y greater than or equal to 5. X value 0, y value 0, which is 0 greater than or equal to 5, it is false. Whenever it is false, what we need to write conclusion? Shade the region opposite to checkpoint. Opposite to checkpoint. Okay. Now here again checkpoint I will consider. So checkpoint I will take again 0 comma 0. Consider 0 comma 0 as checkpoint. Okay. So that 0 comma 0 I will substitute in the given inequality, that is x plus 2y greater than or equal to 6. X value 0, y value 0. Nothing but 0 greater than or equal to 6. This is also false. Whenever it is false, we need to write conclusion like shade the region opposite to checkpoint. Opposite to checkpoint. Okay. So regarding these two inequalities done, now two more we are having, that is x greater than or equal to 3 and then y greater than or equal to 0. Now how to write equation, how to write sentences for x greater than or equal to 3 means, I will write x equal to 3 is a vertical line. X equal to 3 is a vertical line. So if they given in terms of y, then we'll write y is horizontal line. But here x equal to 3 is a vertical line and passes through and passes through 3 comma 0 and shaded region is towards positive x-axis, because x greater than 3 values where we'll get towards positive x-axis only. After 3, 4, 5, 6, so on, towards positive x-axis. So you have to write like sentences regarding x greater than or equal to 3. Now what about y greater than or equal to 0? Okay, so here we'll write y equal to 0 is an equation of x-axis. Y equal to 0 is an equation of x-axis. Okay, so this much is more than enough for the theory part of LPP. So once again we'll revise. The first inequality is x plus y greater than or equal to 5, so that we will convert into x plus y equal to 5. And then if we take x value 0, we'll get 5. If we take y value 0, we'll get x value 5. Now our checkpoint is 0 comma 0. See, after substituting, what we got is 0 greater than 5, nothing but it is false. Whenever it is false, we have to write opposite. Now when come to second line, x plus 2y equal to 6. When x value 0, y value 3, y value 0, x value 6. We will consider 0 comma 0 as our checkpoint. When we substitute, we got 0 greater than or equal to 6, nothing but false. False means what? Opposite to checkpoint. Okay, and then comes the next line, x greater than or equal to 3. So x equal to 3 is a vertical line and passes through point 3 comma 0. Next, y equal to 0 is an equation of x-axis. Okay, so this is about the theory part. Now let's move to the graph. Okay guys, I already drawn the lines for you. For this reference, this is our first line and this is our second line. Okay, so x value 0 and 5, 5 and 0. So that is our red line. The equation of that line is, this is x plus y equal to 5. And next when come to the second part, so 0 comma 3, 6 comma 0, that is our second line. So equation is x plus 2y equal to 6. And our third line, which is x equal to 3. Okay, and our fourth line, y greater than or equal to 0. Y greater than or equal to 0 is nothing but equation of x-axis. Okay, now we got all four lines. One is x plus y equal to 5, x plus 2y equal to 6, x equal to 3, as well as y equal to 0. Now, so for first two lines, what we got, the checkpoint is false we got. For first one also false, second one also false. So false means what? Okay, opposite to checkpoint. Okay, so for that green line, we got above the region, and even for the red line also we got false. False means above the region this side. Okay, now for that yellow line, I told you now towards positive x-axis, so that is this side. Okay, now if you observe which part we are having all the lines regions, so this is the region. We are having yellow line, right? And we are also having red line area, as well as we are also having green line area. So this is called as unbounded. This is called as unbounded feasible region. Unbounded feasible region. So why we are calling unbounded is, this is till infinite. So there is no boundary here. So we'll consider as unbounded. Though it is unbounded, still we'll get corner points. Okay, observe the corner points here. So this is one point. Okay, and this is another corner point, and this is another corner point. So if you observe three corner points we got, I will mention those. So what is this point? This point is 4 comma 2. What about this point? This is 4 comma 3 comma 2. What about this is 4 comma 1. And what about this is 6 comma 0. Now we got three corner points. So these three corner points I will substitute on number line. Okay, so let us draw the number line first. See, serial number, corner points, objective function, that is z equal to minus x plus 2y. So we got three corner points. Those are 1, 2 and 3. So what are those? First one is 3 comma 2 and is 4 comma 1 and then 6 comma 0. We'll substitute one by one. So minus 3 plus 2 into 2 which is 1 and then minus 4 plus 2 into 1 which is minus 2 and then minus 6 plus 0 which is minus 6. So now we got three values. What they're asking question they're asking related to maximize. So which is the maximum value out of that? So this is actually the maximum value. If it is bounded region, if the question is related to bounded region, what we will consider? We will consider maximum value of z is 1 at 3 comma 2 we will conclude. But here since it is unbounded, we should not conclude our answer is 1. So what we need to do now is, since it is unbounded, we consider z greater than 1. Why we are taking greater than 1 means when they are asking maximum, out of this maximum we have to take greater than. So z greater than 1. For example, if they are asking minimum, then we will consider z less than minus 6. So z less than minimum of minimum value we have to take for minimum. Z greater than maximum of that maximum values we have to take. Okay. Now, so what is that z means? What is that z? That is an objective function. Minus x plus 2y greater than 1. So we did na starting from inequalities to equation and equation to points. The same we have to do for this extra line also. So I will write minus x plus 2y equal to 1 and again I will find points. Bounded means this extra line won't be there, but for unbounded we need to draw this extra line. Okay, when x equal to 0, so y value 1 by 2. When y equal to 0, x value 1. So what are the points you got? Points are 0 comma 1 by 2 and minus 1 comma 0. So for this I will do checkpoint here. Okay, so for checkpoint what I will consider? So I will consider 0 comma 0 is checkpoint. So 0 comma 0 checkpoint. So I will substitute in inequality minus x plus 2y greater than 1. X value 0, y value 0. So 0 greater than 1. So 0 greater than 1. Again we got false. False means what? Shade the region opposite to checkpoint. Opposite to checkpoint. Okay, so first we'll draw the line 0 comma 1 by 2 and minus 1 comma 0. So 0 comma 1 by 2 here. Okay, 0 comma 1 by 2 and minus 1 comma 0 here. Now we will join these two lines by using dotted line, guys. Okay, so why we need to draw this a dotted line means because it is a strict inequality, so we need to draw a dotted line. Okay, so this line name is minus x plus 2y equal to 1. Now after drawing dotted line, so checkpoint lies here, right? Okay, checkpoint is down 0 comma 0. We got false. False means which side we need to draw? So this is our new region. Okay, this is our new region. Now if you observe, old region and new region both are coinciding or not? Okay, so to get the minimum value or maximum value, there should not be any common points. So what I will write the conclusion for this is, okay, since there are common points, between unbounded region and z greater than 1. So unbounded region means like old region. Z greater than 1 means like this is new region, like green area I draw, no, that one. So since there are common points between unbounded and z greater than 1, what we'll say is there is no maximum value anta. There is no maximum value. If there are no common points, then what we have to write? Minimum value of z is at 1 anta. But since there are common points between unbounded and z greater than 1, we have tried, there is no maximum value. So this is the key point of the problem. Till now I did 5 LPP sheets. In that, first 3 are related to bounded region. In that, only one point is also there, multiple optimum solutions is also there. So let us watch. See, after watching first 3 sheets, you should also watch sheet 4 as well as sheet 5, because sheet 4 and 5 are belongs to unbounded region. So in that unbounded region also, two types of questions I selected. First one is unbounded and having minimum value. Next one, unbounded but not having maximum value. So what are the differences between when we'll get maximum, when we'll get not maximum? So you can understand by watching all these LPP series and watch further videos also. Thank you all. If this video helped you, do watch the previous sheets in our target 80 by 80 LPP series. Share this video with your friends preparing for second PU mathematics board exams. Thank you for watching, and I will see you in the next video.